Welcome back, everyone. Today I'm just going to go through sketching a sinusoidal function that has basically all the different transformations included in it. Obviously, if you're dealing with one that has a few less, it just makes for a simpler question. So covering this one and maybe one more afterwards should cover what we need to see. Essentially, what I'm going to say here is that what you're going to end up with on this graph is kind of like a rough draft. So that if we wanted to, we could rewrite it onto a graph in a little bit nicer form. The rough draft is what I'm going to see. It's what I'm going to be expecting for you to submit. So if we look at this, first thing I'd say is I want to list off all the important information. The amplitude here is 2. It's this value out front. And in case you've forgotten, the amplitude is, when I look at kind of the general curve, it's the size of the crests and the troughs, the size of the bumps, if you will, above and below the axis of symmetry. So in this case, essentially what it's telling me is take whatever we had before. See if I can do this. So regardless of what the rest of my curve is out underneath here, whether it's sinusoidal or anything else, this is saying the value under the box is what used to give me my y value. I'm now going to double it. So essentially multiply every single value by 2. And I just realized I'm saying essentially a lot. I apologize. I'll try to stop. So the amplitude's 2. That means the graph will go up to, or initially will go up to 2 and down to 2. Obviously there's more information over here that may make a difference later on. So continuing forward, my amplitude is 2. The second value here, the 4, tells me there will be 4 full cycles of my graph in 2 pi. So in the regular graph, maybe I'll sketch it right now. I would start at 0 for sine. I would go up to 1, down to 0, down through to -1, and up to 2. So my normal graph, just the regular y equals sine theta, whoops, looks something like this. Or y equals sine x in this case. And going backwards, exactly the same thing. Hopefully I can hit these a little bit better this time. And so that's my basic curve. Now what I'm going to end up with is in this regular 0 to 2 pi section, I'm actually going to have 4 full cycles in there. So what that helps us determine is what the period is. The period by definition is the length of time for one cycle. So typically it's 2 pi. Now that 2 pi area is going to be split into 4 full cycles, which means pi over 2. And so again, what that's telling me is that in this little tiny section here from 0 to pi over 2, I'm going to have a full up, down, back, up to the 0. So we'll put that in momentarily. The other two numbers, pi over 6 and the 1, are the shifting that's going to occur. Much like it was when we dealt with way back in grade 10, I think you started moving curves around that were parabolas. The x value has an addition or subtraction here. It moves left and right. The number on the end, of course, moves up and down. And as it was also back then, the number you see here is the adjustment to the x value that's going to occur. In this case, if I want to get back to where I was, so where the 0 was, I have to actually have this whole area go to 0, which means that x would be negative pi over 6. So essentially the graph is going to shift maybe the opposite direction to what you expect. In this case, it's going to shift shift to the left, so towards the negative values, a distance of pi over 6. And then we're also going to shift up the value of positive 1. And a student once said to me the way he remembers it is the values that are associated with the x here. The 4 tells me I'm going to get 4 full cycles in here, which isn't too bad with sine curves. With other curves, really what it means is the graph has been shrunk by a factor of 4 in the x direction. This value, when you see a plus here, it actually means we're headed towards the minuses. And so what he had said to me was he always remembers that your x always lies to you. A big number means the graph gets smaller. A plus number means the graph goes towards the minuses. A little bit of a non-mathematical solution or non-mathematical terminology there, but still pretty effective. The y values, of course, work exactly as they should. You're doubling the size of it, and you're increasing the height of it, or increasing the location of it in the y direction. So I'm going to switch to red. So I'm actually going to start putting in the real graph here. My suggestion is, I think the nicest way to do this, deal with these two values, amplitude and period, to start, and then worry about the shifting kind of I'll show you a simpler way to deal with the shifting as opposed to actually trying to make it fit on the grid. So what do we know? We know the amplitude is 2. We know we have to get 4 full cycles in pi over 2, in 2 pi. You have to get 1 cycle in pi over 2. And so what that means is I'm starting here, I'm going up to here, down to here, and then at this point, I'm kind of done my full cycle. Oh, sorry, yeah, that's right. So halfway between these two, I have to get back to 0. And halfway between these two, I'm going to hit my 2 up top. Halfway between these two, I'm going to hit my negative 2 on the bottom. Okay. Now, my measurement's probably not perfect. But again, I've already explained above, sort of as the student in this case, I've already explained above to the teacher that I know the amplitude is 2. I know that there are 4 full cycles. And so the fact that maybe my positioning here isn't perfect is not something I need to worry about too much. So basically I'm going up to here, down through here, and back up again. Now I'll just continue that exact same process, and I might as well fill up the negative 2 pi to 2 pi. It's not going to take too long. So again, that's where I'm going to end. There's my middle. I'm going to head up to halfway between those, down to halfway between those. Okay. Now I'm going to pause the video and just finish that up. Okay, so we have the basic curve now for the amplitude of 2 and the 4 cycles, the period of pi over 2. Remembering that this is where pi was, this is where pi over 2 is right here. As far as the shifting goes, one option, of course, is to redraw the graph, shift it over. We know we want to shift to the left, so this whole thing has to move a distance of pi over 6 to the left. And pi over 6 is, from what we saw yesterday, basically just, each of these is pi over 6, right? It's pi over 6, pi over 3, pi over 2. This is pi over 6, 2 pi over 6, 3 pi over 6. So shifting to the left is not going to be a terribly difficult thing for sure. And shifting up, obviously, is not going to be too tough either. So we can quickly redraw this. Each point kind of shifted over. This one, over approximately to the middle of this one and up again. But I think really for our purposes, once we've already stated that that's what we're going to do, and this one, I guess, is actually an easier one than some others might be, because the 4 and the 2, I sort of got nice, even periods in here. If I had a 3 cycles in here, it would be a little tougher. So what we're going to do instead is, I'm going to stick with my red here. We know that we want everything to move up. And so I'm just going to, again, rough draft this and state that this is where the 3 is. This is where the 2 is. And essentially just cross off the existing numbers and increase them all by 1. So this is my 0, and this is my -1 now. So the graph sort of shows pretty clearly that -1 is my low point. Again, amplitude was 2, but I've shifted it up by 1, and 3 is my maximum value. Same sort of thing with the shifting left. Essentially, what was 0, we want to be at -π/6 now, and so we're subtracting π/6 from each of the existing indicators. So this is now, this was 12π/6. -2π is the same as -12/6. So I'm subtracting one more pi, so this is -13π/6. This was -6π/6. It is now -7π/6. Hopefully you'll have a little bit more room to indicate things neatly. This was 6π/6, so it is now 5π/6. This was 2π, so it was 12π/6. It is now 11π/6. And again, this is the idea here is that this is my rough draft. So this is now the, well, I can just going to indicate that this is f at x that I was looking for. If I wanted to transpose this onto a new graph and make it perfect, I could. I know that I would start at, this is -π/6. So sort of indicating maybe where the middle of the graph is a good idea. And then just any numbers that were already indicated on your graph should be crossed off and remarked so that everything's correct. You know, this point is not incorrectly marked. This point is not incorrectly marked. None of these are. And so if I want, again, if I wanted to transpose this now onto a new graph, it'd be pretty easy. I just move 1 over from where my standard graph sits, and I go up, over 1 and up 1, and then I go up to the regular 3 and so on. So redrawing this properly in a final pretty form would be easy. For our purposes, this is more than sufficient.